Okay, suppose I have a function f of x, and I have my inputs over here, say 1, 2, 0, maybe -1. And when I put in an input, I get an output. This behaves like a function. So say I stick in one value of x, I get out just one y answer. One value of x goes in, I get out just one y answer. Maybe I stick this -1 in, and I end up with the same y answer, but it's just one y answer, so this is behaving like a function. Well, whenever you have a situation like this, we call everything over here in the inputs. We actually don't call it inputs. We call it the domain. And the domain are all values that can be inputs. So the set of those is called the domain. And the range we call the outputs. Let's just say all outputted. Put, is there two T's here? Putted, one T. All output values, we'll just leave it singular. Output values for a given input. Okay, now what if suppose I have this set of ordered pairs. That's x values followed by y values. So x equals 1, then y equals 6, if x equals 2, y equals 10, so on and so forth. First question I'm going to ask you here, looking at this set of ordered pairs, is this a function? Is this displaying functional behavior where y is a function of x? Okay, think about it for a second, maybe pause. Alright, so let's look at this. Well, we have 1, 6, 2, 10, 4, 20, 1, 8, 3, 8. Well, we're repeating 8s here. And more importantly, we're repeating 1s. So if I have 1 as an x value, and I get 6, when I have 1 as an x value, again I get 8. That means that for a given x value, we're having multiple y values. So this does not have functional behavior in the form that I have here, because 1 has more than one y value. So let's change this x value. I set this up on purpose to do this. Okay, so now we have 5, 8, and 3, 8. Well, it's okay to repeat the y value as long as we have different x values. So this does demonstrate y as a function of x. Okay, so since we did that, we can then now look at our domain. And our domain here then is this set of numbers. 1 is a possible x value, 2, 3. It looks like all the first 5 integers. So I did 1, 2, 3, 4, 5. Well, likewise, then our range here is 6, 10. And I don't have to have these in order. Just have to display them. And 8. 8 appears twice. I don't need to write it twice, though. Well, we can do the same thing with equations. So this equation is a function. 3x plus 1. It's an equation of a line. So this looks something like this. Let's change the color of that. I were to map this on here, 2, 3, so I have a slope of 3 over 1. Looks like that's a point. My y-intercept looks like 1 because when x is 0, this b equals 1. So this looks like our line right here. And we should have been doing this in green. I don't know why it switched back to blue. I'll use orange so it really stands out. So there's my line. And as we see, with the if we were to use a vertical line test, let's go with purple. Vertical line test. Anywhere I put this, I'm only going to cross the plot once for every time for every x value. So this is a function. And now I want to ask myself, what's the domain of my function? So what's the domain of this? So that means what x values satisfy this function. So what x values satisfy the function. Well, I could stick in 0. That looks like something. So 0 looks like it's in a domain. When x is 0, y equals 1, or f of x equals 1, I could stick in 1 when x is 1. That's 3 plus 1, y is 4. Let's maybe put this in table form. So we can play around here. 0, 1, 1, 4, 2, when x is 2, 2 times 3 is 6 plus 1 is 7. So it looks like I can put any positive number in here. It's just going to give me one value of y. I can put in 0, it gives me one value of y. Let's go left of 0, minus 1, that's minus 3, plus 1 is minus 2. Okay, minus 2, that's minus 6 plus 1 is minus 5, it looks like. So it looks like even when I go in the negative direction, I can put in a value and it doesn't, the function is not invalid in any way. So here for our domain, the domain is all real numbers. Okay, how about our range? Well, I can see that when I put in some x value, I get some y value, and depending, I can go from minus infinity to infinity, putting in x values, and I'll go from minus infinity to infinity with y values. So the range is also all real numbers. Another way to write this is minus infinity to infinity with these curvy brackets, or I could say x such that minus infinity is less than x is less than infinity. Or I could just write minus infinity is less than x is less than infinity, maybe. So all these are correct ways to express, and of course I could do the same thing up here in the domain, but all these are correct ways to express the range and domain. So there's a lot of functions where all real numbers are a range and domain. Polynomials, Suppose I have, let's look at a simple one, f of x equals x squared. So we've seen that before. If I were to plot that, we've got x, y. If I plot that, when x is 0, y is 0. Let's plot this with orange, I think. So that's this point. When x is 1, y is 1. That's that point. When x is 2, y is 4. It's up here. Then I can go in the negative direction. So it seems like I can go on forever and I will get one y value. So let's go in the negative direction, minus 1. We see that minus 1, so this is minus 1 squared equals 1. Minus 2, well, we end up with the same deal, minus 2 squared equals 4. So I'm getting the same y values that I had before. But these are for different x values. So this is still displaying behavior where y is a function of x. This will actually represent a parabola here. We talked about many times. So then what are we going to do? What are we going to say for our domain? So our domain, then, well again, it looks like I can stick in any x value. So the domain is going to be all real numbers. And then what is our range? Well, if the domain is all real numbers, the range must be all real numbers, right? No, not necessarily. We see here that there's no way of getting any value for y less than 0. We can't stick in any x value and get less than 0 as an answer for y. Every x value, if we're way out here and we choose this x value, way up here, somewhere up here, there's going to be a y value associated with it. No matter, or some negative x value, doesn't matter how big, there's going to be some y value. So our range actually goes from 0, it starts at 0, and includes 0. 0 is part of our answer, so I'm going to put an equal sign, less than or equal to x, and less than infinity. This will go to infinity like this. Notice I didn't put equal to infinity because infinity is not a number. You can't nail it down. It's just a concept. Okay, so that's where we're going to call this one, and we'll pick up again in the next video.